Okay, now let's see how to find the given angle between two vectors. We are given that there is, in the second question, that we have this OA, which is -503, and your OB is 172. We have to find this angle BOA. This is always a good idea to draw this angle roughly, okay? This is your BOA. Now, um, normally from this angle BOA, we take it like, the angle between BO and OA, but it's not like that. When you have to find this angle BOA over here, you should have OB and OA with you. Or if I just draw this again, this is your B, this is your O, this is your A, and I extend these lines here like this. So this is the theta over here. This one is also theta, okay? So this can be like this or like this, okay? So the directions of the vectors, you should note it down. The directions of the vectors between which you're going to find the angle, they should either both be directed towards the vertex, or they should be directed away from the vertex. Like this is OB and OA, the angles are directed away from the vertex. And in this case, if this is over here, they are directed towards the vertex, okay? It should not be like this. You have in your mind, I have to find this BOA. So this is going to be this and this. Yes, it's sahi nahi hoega, because this will give you this angle over here, okay? Because you see both these directions are going away from this vertex. So either the directions, the vectors are directed towards the center, I mean the vertex, or they have to be directed away from the vertex. So in this case, we have both the OB and OA with us. So let's find that angle. So this would be cos, I would write it like this: cos theta is going to be OA dot OB over the magnitude of this OA times the magnitude of this OB. ठीक है बच्चों? So now this OA dot OB is going to be minus 5 into 1 is minus 5, 0 into 7 is 0, 3 into 2 is 6 over. This is going to be 15 plus 9 times, this is 1 plus 49 plus 4. So we have cos theta, that is equal to 1 over under root 24 times this 54. And now you can use your calculators, okay? This cos theta is going to be, sorry, this theta is going to be cos inverse of this 24 times. Yes, did anyone find this angle? What is this angle?
सर 15 के बजाय 25 नहीं लेंगे?
15? Where is 15?
जो OA के मैग्नीट्यूड के अंदर.
Why did I write here 15? 5 square is 25. Oh, what? You see, you're 100% right, beta. This had to be 25 because 5 square is 25. You see, these are silly mistakes, okay? So now tell me, please, what is this cos inverse of 1 over
88.6.
Yes, what is this?
88.6.
This is 88.6 degrees. If you give your answer in degrees, it should be correct to one decimal place, and the radians should always be correct to 3 significant figures. Okay? From here, I'll be taking to a question from past papers. Okay. So we are going to do a question from the past papers. We've been given the coordinates of these points A, B, C, and D, and they are written as the position vectors OA, OB, OC, and OD. It says find the unit vector in the direction of AB. So when I have to find the unit vector, remember unit vector, a vector divided by its magnitude. So for that purpose, I need to have the AB with me first of all. So remember from your O levels, AB is OB minus OA. So that is going to be OB is 3 minus 1, 3. OA is 1, 3, 1. Okay, this is 3 minus 1 is 2, minus 1 minus 3 is minus 4, 3 minus 1 is 2. So let's find the magnitude.
Sir,
Yes,
1, 3 minus 1.
1, 3. Oh, thank you, Beta. So this is going to be 4 over here. Yes, thank you, thank you. So this magnitude of AB is going to be the square root of 4 plus 16 plus 16. So that is 6 units. So what is going to be the unit vector in the direction of AB? So the answer is going to be 1 over 6 into 2 minus 4, 4. And you can divide this 6 inside. This is 2 over 6 minus 4 over 6, 4 over 6. And you can also write it as 1 over 3 minus 2 over 3 and 2 over 3. Okay? So that is how you find this AB. Okay? Next part. The value of P for which angle AOC is a right angle. For which angle AOC is a right angle. Okay. AOC is a right angle. So that means if this is your O, this is A, this is C. So we should have OA and OC to determine this. Yes. So we have to show that this OA dot OC should be equal to 0. Okay. So OA is 1, 3 minus 1. OC is, sorry, this is angle. Oh, we have to find P, sorry. I thought we have to prove that this is a right angle, okay? So we have been given that that is equal to 0. This is 4 to P. So this is given equal to 0. So now the dot product is going to be 4 plus 6 minus P equal to 0. So this P is equal to 10. Yes? Okay. Okay, bacho, next we have to find the values of Q for which the length A of AD is 7. The length of AD is 7. So let me make some space for this. Okay, so the length of AD is 7. So we are given the magnitude of AD is 7. Let's find this AD first of all. That is OD minus OA. So OD is minus 1, 0, Q. OA is 1, 3, minus 1. This is minus 2. This is minus 3. This is Q plus 1. Okay. Now its magnitude is going to be the square root of 4 plus 9 plus Q plus 1 over whole square, and that is equal to 7. I squared both the sides, that is 13 plus Q plus 1 whole square, that is 49. Okay. I am not expanding this because this will save my time. I'll just keep it as it is. That is going to be equal to 36. So this Q plus 1 is going to be plus minus 6. So Q plus 1 is either 6, Q plus 1 is either minus 6. So Q is 5 or minus 7. So these are the values of Q for which um, we have the magnitude of AD, which is 7. Okay. Any question, Bacho? Okay. I'm still having 3 minutes with me. Within these 3 minutes, I can share one thing with you. How many of you remember me telling you about the typical complex numbers? How many of you remember the typical complex numbers regarding the modulus and the argument? You may not remember this, but the ones who really learn them, they can save a lot of time. Okay, like here there are some vectors. If you remember, some vectors, they are typically used now. A vector which has which has its members like a combination of 1 1 and 2 2s. Why do I call that this is a typical vector? What is special in it? Hmm? Let's say you have 2 minus 1 minus 2, like any kind of combination of two twos and a 1. Any hint, bacho? Hmm? Whenever you find the magnitude of a vector like this, the magnitude will always be 3. Look at this, 1 plus 4 plus 4. This is going to be 3. So if you know that there are two twos and a 1, you will be, without any working, can say that, okay, its magnitude is 3. There is another very famous vector, which is a combination of 2, 3, and 6. Guess what is its magnitude? Hmm?
7.
7. Great. This is like 4 plus 9 plus 36. You will see that these matrices being used a lot in these questions. Okay. So let's move to the next video now.